Hey guys, this is Ayushi from Edureka and welcome to this session on Scikit-learn tutorial. Now Scikit-learn is an attractive library for machine learning. So we'll start off this session by understanding machine learning and how Scikit-learn helps us to implement that in Python. Then we'll directly move on to the hands-on part wherein I'll help you guys with the installation of Scikit-learn and then we'll implement various algorithms. So for that we'll be understanding regression and classification techniques followed by a practical demo. So over here, I'll be implementing SVM classifier as well as logistic regression and k nearest neighbors. So I hope you guys are clear with this agenda. So kindly give me a quick confirmation or you can just type in your chat box so that we can proceed. Alright, so I'm getting confirmations. So Anna is clear. So is Bibek, Jenny. Alright guys, since most of you are clear, let's begin with the very first topic of today's discussion, that is what is machine learning. So machine learning is a type of artificial intelligence that allows software applications to learn from the data without any human intervention. And this also helps you to predict the outcomes as well. So let me take a very basic example to explain this concept. So have you guys ever shopped online? So while checking for a product, did you notice it recommends products similar to what you're looking for? Or did you see the person bought this product also bought this? That is the combination of products. And for every user, there is a different set of recommendations. Now, have you ever wondered how are they doing this recommendation or who does these recommendations? So one thing is clear that there is no hard coding involved, but there must be something else for this. So this problem is solved using machine learning algorithms. So what happens based on the user's action, they prepare a smart machine algorithm which is able to predict what exactly is the likely product that a user should buy. And this is something which can be done using machine learning. Now, coming to the programming world, you exactly say what will be the input and what should be the output. That's where it stays. But in machine learning, as and when the data comes, system adjusts itself to the reality and then it behaves accordingly. So this is the dynamic nature of machine learning, or you can say artificial intelligence. That is, it learns from its own. Meaning you have programmed it once, but every time it encounters a problem, it should not be programmed again, which is the main motive of it. So what it does, it changes its code to the new scenarios it discovers. So this is what machine learning is. Now the question comes how we can achieve this. So what we do, we provide it with scenarios, we provide it with the past experiences, we feed in the values, and based on those past experiences, it comes up with a new solution. So machine learning basically it helps us to detect patterns in a data set and it create models over it. And later on we can adjust that models or you can say enhance the accuracy of the model so as to predict the action based on a new data set. Now if you look at the image over here, so in machine learning, what you do first, you train your model, and based on any machine learning algorithm which is built on your data set, you build a model. So by training data, I mean the initial stage, that is every data is considered like a training data. And there if you see there is this feedback loop going on which is performed again and again until we achieve a good amount of accuracy. So this is the whole idea behind machine learning and how machine learning works. Now, machine learning can also be used in various other domains, such as in analytics, it can be used, then it can be used in weather forecasting. It can also be used to predict what will be the stock price next day. And all of this can be done using machine learning, where the system is learning by its own or detecting patterns so that it can take actions whenever it is exposed to a new data set. Next, machine learning is classified into three types, that is supervised learning, unsupervised learning, and reinforcement learning. So we have already discussed all these three types of machine learning. So you can go back to the video what is machine learning. So for now, let me just recap all these three algorithms. So first is my supervised learning. So supervised learning is a process of an algorithm which is learning from the training data set. Or you can think it of as a teacher supervising the learning process, where you know the correct answer, but the algorithm iteratively keeps predicting the training data and is corrected by the teacher. So this learning stops whenever the algorithm achieves an acceptable level of performance. So here what you do, you basically generate a mapping function between the input variable and the output variable and you use an algorithm to generate that function. So it is also known as predictive modeling, which refers to a model of making predictions using some data. Some of the popular algorithms are linear regression, then we have logistic regression, so we'll be implementing this in some time. Then we have decision tree, random forest and naive-bayes classifier. Then comes your unsupervised learning. So in this process of learning, there is no one who supervises the process or there are no correct answer and there is no teacher. So what exactly happened? This is a process where a model is trained using an information which is not labeled. So here the process can be used to cluster the input data in classes on the basis of the statistical properties. So it is also called as clustering analysis, which means you can group the objects based on the information found on the data, describing the objects or the relationship between them. So some of the algorithms include scaling clustering, hierarchical clustering, etc. Then we have reinforcement learning. So reinforcement learning is the learning by interacting with a space or an environment. So this learning can be thought as a hit and trial method, where a reward or a penalty point is given for each action. So let's say if a machine chooses a correct option, so it gains a reward point or vice versa. So what exactly happens? A reinforcement learning agent, it learns from the consequences of its action rather than being taught explicitly. So it selects its action on the basis of the past experiences and also by the new choices, or you can say exploration of data. Next, let's come to the main topic of our discussion, that is scikit-learn, or what exactly is scikit-learn or how does it help in machine learning. So we know that scikit-learn is a library which is used to perform machine learning in Python. Now, it is an open source library which is licensed under BSD and it is reusable in various contexts, encouraging academic as well as your commercial use. Next, it is also built on popular libraries such as NumPy, SciPy, and Matplotlib. Also, the best part about Scikit-learn is that it has many tuning parameters along with a wonderful documentation and a support community. So let me show you that as well. So I'll just open my Google and I'll just type in Scikit-learn. So over here, the first link is my official documentation of Scikit-learn. So I'll just click over it. So as you can see here, this is my official page of Scikit-learn. So over here, this is the introduction that we've already discussed, that it is built on NumPy, SciPy, Matplotlib and is licensed under BSD. Then we have various other things like we have classification, we have regression, clustering, dimensional reduction, model selection and pre-processing, which is again a part of machine learning. So over here we have some applications and some algorithms to solve that. So here, let's say in classification, we have applications such as spam detection or image recognition, in which the algorithms use a SVM classifier, then we have nearest neighbors, random forest, and similarly for all of them. Now let me go back to my presentation. So now the time we'll install Scikit-learn package. So as I mentioned that Scikit-learn is the most popular machine learning package and it has a lot of algorithms already built into it. So what you need to do, you just need to go to your command line and just type in pip install Scikit-learn, or if you're using Anaconda distribution, you can simply type in conda install Scikit-learn. Now, as I mentioned that it already contains a lot of algorithms. So it has a library such as NumPy, SciPy, which makes your work easy with arrays and machine learning techniques much easier. So now if you go back to my Scikit-learn documentation, here you will see that first we have the home page, then we have installation guide and we have the documentation as well. So if I click on installation, so this is the entire page where it tells how you can install SciPy. So we have already discussed that. Then we have a beautiful documentation where it guides you everything. So you can just explore this up and then we have some examples of it as well. So after that we have successfully installed Scikit-learn. So now every algorithm is exposed in Scikit-learn via an estimator. So for that, first you need to import the model. So the general form to do that is from sklearn.family import model. So to take a specific example, let's say I want to perform a linear regression, which is the first machine learning algorithm that we have learned. So we'll just go ahead and type in from sklearn.linear_model import linear regression. So here my linear underscore model is the family and the linear regression, that's the model itself, and then you just need to instantiate that model. So this is how you can implement any algorithm using Scikit-learn. Moving ahead, let us see the concept of regression and clustering. Over here in the documentation as well, we have seen various aspects of Scikit-learn, wherein the first two were regression and clustering. So we'll be going ahead and picking up these two for this session. So here regression is the prediction of a numerical value that often takes input as a continuous value. So as you can see here in the graph as well, we have continuous value of data points. Then we have classification. So classification is the problem identifying to which set of categories a new observation belongs. So let us understand this with an example where you have a given set of male and you have to classify these males into two categories based on the fact that whether the male is a spam or not. So this is a problem of classification. So here basically the goal of classification is to find boundaries or to define boundaries that best separate the different categories of data. Now once these decision boundaries have been framed, it will allow you to differentiate between the classes of data and classify any new value. So in our case we'll be segregating the males whether it is spam or not. So you can go ahead, pick up any data and build your model to classify them as well. So this is the whole idea behind clustering. Now, apart from this, clustering is used in various other domains, such as it is used in medical, where you can predict whether the patient is sick or not. Then it can also be used in animal recognition, where you can classify a set of animal images into different categories. Then you can also use it in machine vision where you can specify faces, or whenever you use a camera, you can see over there, it can clearly identify different faces present. So therefore, a lot of things can be done using classification. So we'll be implementing both of this classification and regression techniques. But first of all, let us explore the data set that we're going to use. Here we have the most popular data, that is the iris dataset. Now why iris dataset? Because it is one of the oldest datasets and carries out easy supervised learning tasks. Now this dataset contains three classes of 50 instances each, where each class refers to a type of iris plant, that is Iris setosa, Iris virginica and Iris versicolor. So it has a strong measurements among all these species, that is the sepal length, then we have sepal width, we have petal length and we have petal width as well. So there are four features which are measured from each sample, that is the length and width of sepals and petals in centimeters. So now let us pick up classification. So here in classification we have different algorithms. We have decision tree, we have random forest, we have naive Bayes classifier and we have SVM classifier as well. So we have already discussed all these three of them. So in this session I'll be focusing on support vector machine, which is also called as SVM classifier. So let us understand this support vector machine classifier. So SVM is a supervised machine learning algorithm which can be used for both classification or regression challenges. But in general, SVM is used for classification problem only. So what it does, it tries to define a hyperplane which can split the data in the most optimal way, such that there is a wide margin among the hyperplane and the observation. So this is your data points plotted in this very graph. So what your SVM is doing, it is defining a hyperplane which is able to segregate data into different categories. So data present at the right side of the hyperplane will belong to a different category, whereas data point present to the left side of the hyperplane will belong to a different category. So it is considered one of the most efficient algorithm in machine learning for performing classification. Alright, so I have a question over here. Okay, so Vivek asked me what is a hyperplane. So hyperplane is just a generalization of a plane. So if you talk about one dimension, a hyperplane is called a point. So let me show you as well. So here we're talking about one dimension. Let's say we have some data points over here. So this is the point, or you can call it as a hyperplane, which will categorize or segregate the other points in two halves. So this very point is considered as a hyperplane in one dimension. Now, if you talk about hyperplane in two dimension, let me do that as well. So I have some data points. Let's say I'll take a different color this time. So these are my data points. Now I want to draw, or you can say I want to create a hyperplane which will best segregate these data points. So over here my hyperplane would be a line. So this is my line, which will basically segregate your data points into two halves. So basically a hyperplane allows you to categorize the data points into different classes, or you can simply say it segregates the data points into different categories. So I hope I answered your question, Vivek. Okay, Vivek is saying yes, certainly. Great, Vivek. So let's move ahead now. So now moving ahead, we have a SVM use case. So now what we'll be doing, we'll be performing an SVM classification on the iris dataset. So we've already understood what exactly is an iris dataset and what features does it contains. So here is this problem statement. So over here we have to use the SVM classifier on the iris dataset, and you have to create a model which classify the flowers based on the features. So we have features such as sepal length, sepal width, petal length, and we have petal width as well. And we have to classify the flowers. So here we know that we have different species of flower, that is Iris setosa, virginica and versicolor. So now let us go ahead and build our model for that. So I'll just go to my Jupyter notebook. Alright, so this is my Jupyter notebook. So I'll just go to Python 3 and I'll give a name to it. Let's say I want to name it as Scikit-learn tutorial. Alright. Okay, so now let me just brush up the basics of Jupyter notebook. So first of all, if you want to type in any headers, or if you want to give heading to your Jupyter notebook, you can simply type in hash, and you can let's say you want to type in heading 1, and you can go to the markdown and you can just run this. So the shortcut to run this is shift and enter, or you can just directly go over here and click this cell. Then if you want it in this header 2, so you can just type in 2 hash and write in any header. So let's say header 2, and just run this. Alright, I have to change it to markdown, and you can just run this. So this is my header 2. Similarly, you can do it for header 3. So you just need to type in 3 hashes and you can say header 3. Alright. Now if you want to bold your heading, so for that what you need to do, you just need to type in to asterisk, and you can say, let's say I want to type scikit. I haven't marked down, so I just mark down it, and now let me just run this. So this is my bold text. Now similarly, if you want some bullet points in it, so now first I'll just set it to markdown. So I say markdown. So over here I'll say, let's say point 1, and then I want point 2. So this will basically show me the bullet points. So let me just run this. So as you can see, I have bullet points over here. So this is just the basics of Jupyter Notebook, and also for the shortcuts you have everything over here. So you can go over help and you can click on keyboard shortcuts. So here it will show you the list. So you can just go over this once. So now let us implement SVM classifier. So I'll just give it a heading 1, that is SVM classifier. It should be capital. So I just capitalize it and done. Now the first thing you have to do for machine learning is you have to import the library. So what you will be doing is from Scikit-learn import SVM, that is my SVM classifier, and I just run this. Alright, so this is working fine because I've already imported Scikit-learn. Then what I need to do, I need to import datasets as well. So I'll say from Scikit-learn again, from Scikit-learn import datasets. So this is the default dataset that we have talked about, which is the iris dataset. So here we have seen that Scikit-learn is my Scikit-learn library, and we have SVM classifier, which we are going to use. Then we have just imported the dataset. So these are the two models which belongs to the Scikit-learn library. Now what you need to do, you just need to load the dataset. So for that, I'll take a variable, let's say iris, and I'll just, using the datasets, I'll just load my iris dataset. So I'll say load iris method. So I'll use load iris method to load it. Okay, so here it should be equal to, and it should be datasets. So using this load iris function, we have just imported my iris dataset. So now what I need to do, I just first let me just print the type of this iris. So I'll just run this. Now as you can see here, we have data type called as bunch. So this bunch basically contains the iris dataset and all the attributes. So one of those attributes is data. So let me just type in iris.data. So this will basically print me all the features, or you can say all the specifications of your iris dataset. Now as you can see here, I have 4 columns and I have some 150 rows. Now, but these are the measurements. So I've already told you that iris dataset contains some specifications of the flower. So we have sepal length, we have sepal width, we have petal length, and we have petal width as well. So now you want to know the feature name. So you can just type in iris.feature_name, feature_names, and just run this. So here we have sepal length in centimeters, then second column stands for sepal width in centimeter, then petal length and the petal width. So now we have these measurements. Now there is one more attribute called as target. So I'll just say iris.target, and I just print this. So now what exactly is target? So target is what we are going to predict. So here we are getting the values as 0, 1 and 2. So here 0 represents your setosa, or you can say iris setosa. Then 1 stands for your versicolor and 2 stands for your virginica. So you can also type in here iris.target names. So as you can see here, I have 0 for setosa, then 1 for versicolor and 2 for virginica. So this is how you can explore any data set. So now let me just run our SVM classification. So till now we have just imported our SVM and we have imported the dataset. So now what we need to do, we need to create different arrays for storing our dependent variable and independent variable. So for independent variable, let's take it as X, and we'll store the value that is the features of it. So I'll say iris.data and we'll say colon, comma 2. So this is similar to ilog, which is used for row selection or column selection. Now for columns, we'll be considering the first 2 features of it. So now let me just go ahead and create my dependent variable as well. So I'll take it as Y. So I'll just say iris.target, which is the value I need to predict, or you can say which is the species that the flower belongs to. So here the class of each observation, or you can say the data point, is stored in .target. That is the attribute of the data set. So we have assigned this to a dependent variable, that is Y, and we have already understand what exactly is my target. So we need to specify whether it is a setosa, it is a versicolor, or it is a virginica. So here I have just set my independent variables and dependent variables. Now what I need to do, I need to split my data. So I'll be splitting data into two subsets, that is my training data and my validation, or you can say the testing data. So I'll be just typing in xtrain, x underscore train, then x underscore test, then y underscore train, and y underscore test. So before that, first let's go ahead and import clause validation. So I'll just insert a cell over here, insert cell above, and over here I'll be writing from sklearn dot cross validation import my train test split. So as I told you that we have to split the data. So I'll be splitting the data in my training subset and my testing subset. So then I'll be just specifying the size of it. So I'll just use this function, that is train test split, and I'll pass in some arguments to it. So I'll be passing independent variable, that is x, then the dependent variable, that is y, and I specify a size to it. I'll say I want to split the data in, let's say, 0.2. And then what I'll be doing, I'll be giving a random state to it. So here random state is nothing, but it just ensures that each time we run this code, we'll be getting the same sampling. So you can specify any number to it. So in our case, let's take it as 4. So here I have forgotten an underscore. Alright. So this runs fine now. So now what you need to do, you need to use SVM to build a classifier which helps to classify whenever we are providing a new data or any data regarding a flower. So you can conclude to which species it belongs to, or you can say which flower it belongs to. So then what I'll be doing, I'll be creating a model for that. So I'll say model equals to svm.svc, and inside that I'll be passing kernel which is equal to linear. And then finally I'll be just fitting my model. So I'll say model.fit. Alright, so here I just need to fit my model, that is model.fit, and I have to pass in my parameters, that is my independent variable, that is my x train, and the dependent variable, that is y train. So now you must be having a question that what is this kernel? So SVM has a technique called as kernel that adds a new feature which is required so as to define a hyperplane, which can basically segregate your data into different classes. So now let me just explain this with an example. So I'll go back to my paint. I'll just create a new file. So suppose we have some data points. Let's say, so suppose we have data points plotted somewhat like this. Then we have a different set of data points that have been plotted around it. So I'll take it with a different color. Let's say, let's take green this time. So what you need to do, you need to define a hyperplane that segregates these two classes very well. That is a tedious task over here. So let's suppose you have x values over here. So this is my x-axis and I have y over here. Alright. So what your kernel will do, it will extract a new feature such as the whole data points can be plotted and can clearly get a hyperplane segregating different classes and data points. So we'll go ahead with some features such as, let's say z is equals to x to the power of 2 plus y to the power of 2 again. And your whole model will be reformed as, let's say, I'll take it as black. So let's say this is your new model. Now let's say this is your z-axis and x is this. I'll take a different arrow for this. So this is my x-axis. Now once you apply this transformation, you can clearly see your data points plotting something like this. So let me just plot some data points. And I'll plot one more set of data points. Let's say yellow this time. So now you have one set of data points plotted like this and another plotted like this. So over here you can clearly define your hyperplane, which is segregating your data set. That is your main goal. So this is what your kernel does. So basically kernel provides you with a functionality which takes the low dimension input space and transforms it into a higher space in order to convert not separable problems into separable problems. So that's what we're trying to do over here. So now we have set our kernel parameters as linear because we are going ahead with a linear hyperplane for our problem. So since our model is ready, we can go ahead and perform some predictions to predict a class of a particular flower based on the test data set. And therefore we can check the accuracy there. So now what we need to do, you just need to type in accuracy and I'll say model.score And inside this, I'll be giving the independent variable of test subset, that is X test. I will compare the predicted outcome, that is Y test. And then I'll just print my accuracy. So here it is saying that you have to import it first. So what I'll be doing, I'll be inserting one cell above, or you can say below that. I just need to type in from dot metrics import accuracy score. So alright, this happens sometimes in Jupyter Notebook, whereas if you run the same code in PyCharm, it will run fine. But now in Jupyter Notebook, it gives a problem of space. So what I've done here, I have just converted all my arrays into one dimension. So as you can see here, I have just converted my xtrain, xtest using this function of reshape. Then what I've done, I have just fitted my model over here. So this I've already discussed that we have used svm.spc, and I've told you the usage of kernel as well, and then we applied linear model to it. Then we have just fit my model with the new values, that is xtrain mod and ytrain mod. After that, we have just used a variable, that is ypred mod, and inside that I've used the function of predict. And finally towards the end, we have calculated the accuracy using this function accuracy score, and then we have passed the variable of test subset. So now we have calculated the accuracy of 96%, which is quite good. So let me just recap all of this once again. So here I'll explain you the basics of Jupyter Notebook, how you can type in heading 1, header 2, header 3, then bullet points to it. Then we have learned about SVM classifier, where we have first imported SVM and data sets. Then we have just loaded my iris data set. We have printed the type of it, which is bunch. Then I've just printed one of the attributes, that is data. So this will basically tell me all the specifications for my iris flower. Then I've just printed the feature name of it, that is the sepal length, sepal width, petal length and petal width. After that, I have printed one more attribute, that is target, and then I have printed the name of it as well. So that is my iris setosa, versicolor and virginica. Then I have just set my dependent and independent variable. So I have my independent variable as x, which says the features 2, where I just considered my first two features. And then I have my dependent variable, that is my y, or you can say the value which needs to be predicted. After that, I have just imported cross validation and import this function, that is train test split. So as to split the data between a training subset and a testing subset. Then after that, I have used this function train test split and I've passed on the variables and given a size of 0.2, and I've given a random state value as 4. So this value can be anything and it is used whenever we need the same sampling every time. Then what I've done, I've just converted all my arrays into one dimension. You don't need it sometime, but so sometimes Jupyter throws this error. So what I've done, I've just imported all these arrays into my one dimension. So I've used the function reshape, and then I've simply used a model, that is svm.svc, and I've used the functionality of kernel to linear model. Then I've just fit my model and pass on my independent variable and dependent variable. Then I've just calculated my accuracy. So over here, I have first imported my accuracy score, that is the predefined function. So using this predefined function, I have just calculated my accuracy. So this was all about my SVM classifier. Next, let us implement k nearest neighbors. So here, first of all, you need to select the value of k, which will basically define your nearest neighbors. So here you have to search for k observation or any number in training data that are the nearest to the measurement of unknown iris. So I'll go back to my Jupyter and let us implement this as well. So I'll just insert some cell below. So now we'll be understanding KNN, that is, so I'll give it a heading of header 2, that is my KNN, or you can say k nearest neighbors. So I'll just go to Markdown and I'll just run this. So again, what I need to do, I need to load my data. So I've already loaded my iris dataset. Next, what I'll be doing, so I'll just do it once again. So I just load my iris dataset. Alright, so I have to first import it. So I'll say from Scikit-learn. So here I'll just import this load iris function. So I'll say from Scikit-learn.datasets import load iris. So Scikit-learn.datasets is my module and load iris is the function from the SK module. So here I have just loaded my iris dataset. So now what I'll be doing is I'm having a variable called as x, which has iris.data, and I have y, which is equal to iris.target. So we have already discussed this above. let me just print the shape of this. So I'll just type in print, or you can simply just type in x.shape. So as you can see here, I got a 2D array with 150 rows and 4 columns. Similarly, you can do it for y as well. So you can say y.shape. So here we have 1D array of length 150, or you can say we need just one response value. So now as we have discussed, to create a model, we first need to collect the data. We need to clean that data, or that is something which is not required in my iris data set. Then we need to train and test the data. Then what we need to do, we need to split the data, that is into training subset and testing subset. And finally, we can calculate the accuracy. So let me just implement this. So I'll say from sklearn.neighbors import kneighbors classifier. So next what you need to do, you need to instantiate the estimator. That is, you have to make an instance of the model. So for that, what I'll be doing, I'll be typing in knn, kneighbor classifier, and inside this I'll be passing in nneighbor, and I'll pass in some value to it. Let's say my value is 1. So this value will basically look for my 1 nearest neighbor. So now let me just print this knn value. So here's a spelling mistake. Okay, so here was just a spelling mistake of neighbors. Alright, so here as you can see, I have algorithm, I have leaf size, I have metric parameters, and all these things. Next, what I'll be doing, I'll be training the data, or you can say it basically it will learn the relationship between the feature and the response. So what I need to do, I need to fit the model. So I'll say knn.fit, and inside this I'll be passing the features and the response, that is my x and y. Then once your training is done, you need to predict your data as well. So we'll be predicting it for new observation. So I'll say knn.predict, and I'll pass on some dummy values to it. So let's say 4, 5, 6, 2. So as you can see here, we are just getting the same error that we got in a previous example, that is reshaping your data using the array.reshape function. So this error we have already encountered in the last example when we are discussing about SVM classifier. So over here what we can do, we can simply convert this into a NumPy array. So for that, let me just import my NumPy. So I'll say import NumPy as NP. Then I'll be taking a variable, let's say A, and I'll say np.array, and I'll pass some values to it. Let's say the same value, that was 4562. So now let me just print the shape of it to see whether it's working or not. Let me just print it. Alright, so this is working. So now I'll just repeat the same step, that is knn, and using the predict function, I'll predict the outcome of it, or you can say the response of it. So I'll pass in the value, that is A, and I'll just run this code. So as you can see here, I'm getting an array that has a 2 value. So over here, Scikit does not know what this 2 represents. But here, we already know that 2 represents for iris virginica. So that is how we have concluded that for these set of values, we're getting the output as 2, or you can say the iris virginica. Now similarly, you can try it with different k values. So here you have given the value of 1, you can change it to any other value. Let's say if I give it a value of, let's say 4, I'll just run this. And now if I run the last statement, I have to fit this one. And then let me just run this now. Alright, so it's giving me the same output, that is 2, which basically represents my iris virginica. Similarly, you can change the value of n neighbors. Okay, Anna is asking me a question this time. So she is asking me, how can you find an optimal value of k, or the nearest neighbors? Okay, this is a very good question, Anna. So there are different parameters for doing it. So for that, what you need to do, you need to tune your model with different values of k. So we will be taking this forward in my next session, Anna, wherein we'll work with bigger data sets and we'll create clusters as well. So all your doubts regarding this question will be covered in my next session. Next, any other doubt guys you have regarding what I've explained till now? Alright, since you guys don't have any questions, so let me take one more example. So here we have taken an example of k nearest neighbors. So let us implement logistic regression on the same model, or you can say on the same data set. So for that, what I can do, I have to first import my model. So I have to type in from sklearn.linear model import logistic regression. So next I need to instantiate this model. So what I'll be doing, I'll say log r or you can say log regression equals to logistic regression. So then I just need to fit my model. So I'll say log r logreg dot fit, and I'll pass on the variables, that is my x and y. So this is my logistic regression, guys. So now what I need to do, I need to just type in the variable name, that is logreg, and using the predict function I can predict the value. So I'll take the same example. So I have a over here, and I'll just run the code. So here again I'm getting the output as 2, which basically represents your iris virginica. So that is how we can implement SVM classifier. Then we have implemented k-nearest neighbors, and then finally we have implemented the same logical regression in the same model using the iris dataset. So that is all for this session, guys. So guys, it's time for questions now. So do you guys have any questions? So you can just type in your chat box, or if you want I can unmute you as well. Okay, so Anna doesn't have any question. Okay, Jenny is also saying no. Okay, so I don't see any questions right now. So no worry guys, even if you have questions later, you can just come up with those in my next session, or you can just contact our support team which is 24/7 available for you. Alright, so let me just recap the things that we have covered in today's training. So first of all, we understood what is machine learning, and then we got into Scikit-learn, which is a Python package for implementing machine learning. Then we took a deep dive into it, and we understood the installation and the various steps involved in machine learning, such as loading the data, analyzing it, splitting the data into train and test subset, and finally finding out the accuracy of it. Then we've gone through regression and classification techniques, where we started with the implementation using the SVM classifier. Then we moved on to the k-nearest neighbor, and finally we implemented an algorithm of logistic regression. So that's all for today, guys. Hope you have enjoyed this session. So if you guys have any doubts or any queries related to any of the topics that I've discussed today, please feel free to ask me, or you can come up with your questions in my next class. So till that time, I would take your leave. So thank you so much. Bye bye.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!